We're going to do the converse of the Pythagorean theorem. We're on section 8.3, the third section of this 8 unit. Now, the Pythagorean theorem said that if you have a right triangle, then a squared plus b squared equals c squared. Well, now we're going to go backwards. Today we're going to use the Pythagorean theorem to decide if we have a right triangle at all.
Oh.
Okay? So instead of saying if it's right, then a squared plus b squared equals c squared, we're going to look at a squared plus b squared equals c squared and see if it's right. Okay? So here we go. Here's an example. You just watch this. Do not even write anything down. Okay? I have a triangle here, and it's got an 8 on one side, a 7 on another side, and a square root 13 on the other. We need to decide if this is a right angle, a right triangle. Could we make this one over here be a right angle?
Hold on, I gotta change my mode.
Okay? All right. So what we're going to do is we're going to plug this into the Pythagorean theorem. You actually should check. This is actually 10 point something or other, right? Because this is square root 100 is about 10. So this is the longest one. That's the one that goes for the C. So we're going to plug it into the Pythagorean theorem. And I am putting a question mark. Is everybody watching up here?
Yes.
I'm questioning, is this equal? Let's check. So if I square the square root 13, should be 113, what will I get?
Like
113.
10.6.
Square the square root of 113.
Yeah, I'm
Oh,
just gonna,
113, yeah.
so the square root goes away, right? And this will be 64, and that will be 49, right?
Yes.
Okay, so what is 64 plus 49? Is it 113?
Is it? You tell me.
Yes.
Yes, it is. Okay, so when you do this whole checking thing, if it equals at the bottom, then yes, it is a
So
right
can we
triangle.
put a question mark above our equal sign?
Not anymore. The question was going on. We don't know if it's really equal, and now you don't.
No, I mean like.
Yes.
A
Go ahead.
total.
Put a question mark at the top because you're not
So
sure.
only if it equals each other. If it equals out.
Yeah. So if this would have
It
been,
is a right triangle.
that's correct. If we would have gotten like 102 on that side instead, it would not have been a right triangle.
Got it.
Okay. They have to equal for it to be right triangle. All right. And since we know about right triangles, we can also do other kinds of triangles, obtuse triangles and acute triangles. So here we go.
Cool.
You have memorized these already, so no big deal. We can use the version of the Pythagorean theorem to determine if they're acute and obtuse. I'm going to bring them up. So right here, come on over here and watch me for a quick. Do me a favor, guys. I need you to close your notebooks. Keep your hand in it. I need you to pay attention up here real quick. You guys can see what memorizing those things does for you. It makes you be able to go ahead. That's great, but I need you to stick with me. It's going to be acute if the Pythagorean theorem is very similar, except for an equal, it'll be a less than. Yes. All right?
All I need to do is write yes.
If it'll be obtuse if it's like the Pythagorean theorem, except for a greater than. And so then we can just plug it in and check. All right? Let's do some examples together. Except first, you got to watch this. This is really cute. I found this online. I've been doing these joke things, so we're going to do another joke. So we got this right triangle. She's up here, and he's down here, okay? And this is the new dating angle.
So you're saying with this joke that women are better than men?
No, not at all.
Oh, is that what you're saying? Oh, okay.
No,
Yeah,
we're
Okay.
and if this is an isosceles, they're equal.
When
Okay?
it comes to math, you're probably better, but still, women are better than men.
All right, so here we go. She's going to say,
I wouldn't.
hi, you're a cute angle. And he's going to say, thanks for the compliment. Why is that funny?
Oh my.
It's not.
What is it? What is this compliment thing?
I
What's a
don't wanna know.
A complementary angle?
Yeah, we got you.
You got you guys. Those add up to be 90
We
degrees.
got you.
So funny. I love it. Okay, here we go. Let's do, watch this real quick.
I was trying to find your answer.
Now, shh, I need you to review something back in the day. You haven't seen this for a while, so pay attention. Come back up. Reel you in.
Gotcha.
Not all measures of become triangles. Sometimes they're acute, sometimes they're obtuse, sometimes they're right, and sometimes they're not even a triangle.
It's like
All right?
equal 180.
If you remember,
Yeah,
Oh,
that's
yeah.
not
the measures have to do something to be able. The measures have to be able to. What do they have to do? If you got a 6, 5, and 11, what do they have to do to make sure that it is a triangle? We did this like last semester. How do we check? If I gave you on a problem and I said, if I have a 6 inch and a 5 inch and an 11 inch, does that make a triangle?
We add them up. Oh wait, no. They both have to be less than. Like 2 of them have to be less than
The third?
The third.
So if I add this 5 and
Oh, yeah,
6, it has to add up to be what, more than 11 or less than 11?
More.
more. It
that
can't be
true?
the same number.
And it can't be the same, so it has to be greater?
6 and 5 has to be greater than 11.
Uh-huh.
5 and 11 has to be greater than 6. And 6 and 11 has to
Now,
be
you
greater.
noticed something. You noticed that automatically, if you start with 11 plus anything, it's going to be greater than those, right?
Yeah.
So you don't even have to check that one. You just have to check the two small ones
Yeah.
that they're greater than that one, right? And it is greater because it has to be. So this is the rule, and you guys have done this before.
Now, what I wanted to ask you, if it's the same amount, so if, because that 6 plus 5 is 11,
Yes.
it's still...
This would not make a triangle because
Would not make a
the
triangle.
rule says the sum of the two
No,
sides must be
would.
larger or greater than the third side. So it has to be greater. So 5 and 6 was not greater than 11; it was equal to 11. So that would not have made a triangle. Okay.
Or would it have made an equilateral triangle?
It would not have made an equilateral triangle because equilateral triangle has to be all three of the same.
Oh, that's true.
Okay? All right. Any other questions? These are good ones. All right. So this will not create a triangle. We just concluded. Because, oh, well, this one. And which two do we need to check for
I
this?
don't know.
33,
Just the
38,
30
and 77.
Is that going to,
Yeah.
definitely going to be, I mean,
No.
77 is almost 86. You only have to
Yeah.
get like
Yeah.
9 and more to get it.
No.
So it's going to be a triangle.
No.
Mm-hmm.
Definitely will be.
No.
I'm sure
Alright.
it'll be like 1 or something. Just like divide it.
Well, because 77 is almost 86. I mean, you only have to add like 9 to get there. And 38 is going to way push it
No.
over, right?
Nah.
Yeah.
I don't believe that.
You don't say no, you just say no.
You can add the 38 and the 77.
Oh, I'm gonna kill it.
And you're going to get 115.
No.
110.
No.
Oh, wait, no, I
38.
did 33. Sorry. my
30.
bad.
Okay, I was like, wait a second. 8 and 7 is 15.
Sorry,
115.
yeah,
Yeah,
115. Sorry, I
115.
typed the wrong thing in my calculator.
Okay.
No.
Yeah.
115 is bigger than 86. All right, let's
Just a
do some
little bit.
examples. Here's the ones we're going to do together. 1, 2, 4.
is yes and 2 is no.
1, 2, 4, 7, 8, 10, and 13. You can circle them if you'd like. These are the ones we're doing together. I want you to do me a favor. Okay, we're going to do number 1 together. And it asks us to state if this is a right triangle. We're going to do that by plugging it into the Pythagorean Theorem. We're also going to do it a second way after that. We're going to take this. This is one of the A, and this is B, at least the legs, A and B, and this is C. Your Pythagorean Theorem states that C squared equals A squared plus B squared. So we're going to fit our C squared. That's the hypotenuse. That's the longest one, if this is the hypotenuse. So we'll have 15 squared equals, doesn't matter which one I call A and B on those. I'm going to go 12 squared plus 9 squared. 15 squared is 225, and 12 squared is 144, and 9 squared is 81. Do these add up? 144 plus 81, I'm going to add, that's a 5. Add, that's a 12, carry the 1, and 225, yep, 225 equals 225. So these we should have put question marks on. Were they equal? Yes, they were. Is it a right triangle? Yes, it is. Now there's 2 ways to do this. So I'm going to clear my screen here. And we memorized 2 Pythagorean triples, a 3, 4, 5, and a 5, 12, 13. Excuse me, yes, 5, 12, 13. This is one of them. But you say this doesn't look like a 3, 4, 5. It doesn't have a 3 or a 4 or a 5. But if I took this one right here, the 3, 4, 5, and I multiplied by 3, I would get 9. Multiply that by 3, I'd get 12. And multiply that by 3, I'd get 15. So yes, this is a right triangle because it is a Pythagorean triple. Those Pythagorean triples are very powerful. If you know them, you can jump to the answer without having to do the Pythagorean theorem. Let's do number 2 now. Number 2, is this a right triangle? Well, let's first check, is it a 3, 4, 5? Well, 10 times anything doesn't equal 3 or 4, so no. Okay, so maybe it's not a 3, 4, 5. Maybe it's a 5, 12, 3, 5, 12, 13. Well, I have a 3. I mean, I have a 13, yes. And I have a 12, yes. but this 10 does not work. I'm not even thinking that it's a right triangle, but I want to just double check. Maybe I just don't know this Pythagorean triple. So we're going to double check. Here we go. So we're going to go a squared plus b squared equals c squared. The 13 is the longest one, so we're going to put that here. And 13 squared is 169. It doesn't matter which one we do first with the 12 or the 10. So I'm going to do the 12 first, and that's 144 when I square it. When I square 10, I'll get 100. Does that equal 169? Well, let's check. 100 and 144 is 244. And I should have been putting question marks there. No, it is not. These do not equal. No, this is not a right triangle. This is number 4. We're going to do this together. We're going to decide if it's a right triangle, but we now have these square roots in here, and they might look really ugly and scary. So it's actually not so bad. Let's do it together. I'm going to write the Pythagorean theorem. C squared equals a squared plus b squared. That c squared could go on the other side if I wanted it. I'm going to put it there. The largest one, that's when you have to figure out what the largest one is. And if I made that under a square root, it would be the square root of 49. And so this one's the biggest because it's bigger, okay? All right, so we're going to put square root 86 in here. And we're going to square it. These two are the legs. So it doesn't matter which one we do first. I'm going to do the 7 squared and the 37 square root next. Now, oops, the square root and the squares zap each other out. So it just becomes 86. 7 squared is 49. And the square and the square root zap each other out, and we get 37. If I add these together, let's see what happens. When I add those two, that's going to be 16, carry the 1, and I add those two, it's a 7 and an 8. 86 does equal 86, and we were checking if these were equal, so we should have had question marks on them. All right. And yes, these are equal, so it is a right triangle. Okay, this is number 7. We're going to be doing something a little different. Instead of deciding if it's right, we're going to decide if it's one of these 3. Acute, obtuse, or right. And I look at this one, and I notice some numbers. I notice a 5, a 12, and a 13. This is a Pythagorean triple. And we know that Pythagorean triples make right triangles. So you don't even have to put it into the Pythagorean theorem. This is automatically right. Now number 8 is the same. It has the same thing. We're looking for acute, obtuse, or right. So we're going to look at this and we're going to see if it's a Pythagorean triple. Is 9, 10, 15? I can't even reduce those down to a 3, 4, 5. I can do a 3 and a 5 if I divide by 3, but I can't do that with the 10. It's 5, 12, 15. Should be 5, 12, 13 is neither one of those. So I'm going to just have to check. When I do that, remember to check for obtuse or acute or right. Right, we're going to decide if it's equal. And if it's obtuse, it's going to be greater. And acute is going to be less than. Remember that right was equal. So I'm going to leave a little blank there because I don't know what it's going to be. I might even do it in a different color. Here we go. So I'm going to do the longest one, which is the 15, and I'm going to put it here. So 15 squared. I don't know what that is. Maybe I'll even put a question mark. The next two doesn't matter, the 9 and the 10, so I'll do 9 squared plus 10 squared. 15 squared is 225, our blank. And I've got 81 and 100 when I square them. So I'll have 181 and I'll have 225. So it is greater. So that means if it was greater up there, that would have made it obtuse.
You're
Do
gonna
them
say
with
don't go
me.
ahead.
All right, here we go. I'm going to write your 9 square root 2. I'm going to square the whole thing. Leave a blank because I don't know if it's greater than or less than. I'm going to take my 5 squared, and I'm going to add to 9 squared. All right. My squared and my square root are going to cancel each other out. And it's going to multiply. That 2 squared will become, 9 squared will become 81 times 2 is 162. I don't know if that's greater than or less than, but it's going to be 25 plus 81. When I add 25 and 81, I'm going to get 106. And it's going to be greater than, so that makes it obtuse.
9? 9. 18.
All right, number 13, we're going to add those, there's 2 short ones to see if it's greater than the largest one. We're going to do that because we're going to see if this even makes a triangle altogether. So we're going to take this 8 and the 7, add it together, and I get 15. 15 is greater than 14, so yes, this does make a triangle. This is review. We have done this in the past. All right, let's review really quick what we've done. This is what we've done today. You ready?
Mm-hmm.
Yeah.
We've decided if we have a right triangle by plugging the Pythagorean theorem. If we get an equal, we know it's right. If it's less than, it's acute. And if it's greater than, it's obtuse. The sum of the 2 sides must be larger than the third side, just so we make sure it's a triangle altogether. I hope you've enjoyed this. Goodbye.